Hello everyone, today our group would be discussing about reaction kinetics. So far, we have discussed two main parts of reaction kinetics, which are methods to measure rate of reaction and measuring rate of reaction using graphs. First of all, we define rate of reaction as change in reaction divided by time taken for the change. There are two main ways of measuring the rate of reaction: sampling and continuous. For sampling, we are taking a small amount of sample at various times and would carry out chemical analysis to find out the amount of products that are formed. During that reaction, we need to quench the sample to stop or slow down the reaction.
One example is by cooling the sample in ice. This would cause the temperature to decrease, therefore the rate would also decrease. Furthermore, chemical analysis could be, for example, putting an X on a paper and the beaker gets cloudy. Analysis is done until it's cloudy enough that the X couldn't be seen. For continuous, it is the physical property of the mixture that is monitored over a period of time. So we don't need to take samples time by time, so it is much easier. Few examples include the change in color, electrical conductivity, temperature, concentration, pressure, and volume. There are some apparatus like colorimetry, gas syringe, dilatometer, conductivity meter to help observe these changes.
For colorimetry, it could be used on an occasion when the color of iodine fades, since iodine is black when solid, purple when gas, and brown when liquid. For conductivity meter, it could be used if electric conductivity increases over time, and for dilatometer, it could be used when there are changes of volume. Continuous method can even be used if reactants have ions. Next, we will move on to the next part of the video, which is how do we use graphs to find the rate of reaction. Measuring the rate of reaction using a graph is simpler than it sounds. If we see a graph of concentration against time, we can use the gradient to get the rate of reaction.
To do this, we can firstly draw a tangent, a line that touches the point in the graph. Next, we should also identify the triangles by drawing a straight line horizontally and vertically. Now, we can obtain the two different x and y values from each ends of the triangle. To find the gradient, we simply find the difference of the y values and divide it by the difference of the x values. When calculating the rate of reaction, there are some things we should not forget. We have to include the units for the rate, which is the mole per dm cube per second. Make sure to also draw bigger triangles to ensure that the data obtained is the most accurate. When we draw the tangent, make sure the lines do not cross the line of the graph, and most times, initial rate is steeper, and we should also convert the minute to seconds.
To determine the reaction rate, there are two graphs that we should pay attention to: the graph of concentration over time and rate over concentration. In each graph, there are three orders of reaction. For the graph concentration over time, as the line gets steeper, the order of the reaction also increases. The first is this straight slant of line, which is the zero order reaction since it shows a constant reaction. Then we will have the first order of reaction, while this one is the second.
And the rate over concentration graph, this horizontal line is a zero-order reaction to show a constant reaction. The first order has a straight line because the rate is directly proportional to the concentration. For the second order reaction, it has a quadratic graph because the rate is proportional to the square of the concentration. When writing the rate equation, it depends on the order of the reaction. In the zero-order reaction, the concentration of substance is raised to the power of zero, and the same rule applies to both first and second order reaction, respectively. Thank you for listening.